Hello everyone, Mr. Fawcett here, and we have another Algebra 1 lesson. Today we're going to focus on converting word expressions to algebraic expressions, as well as going the other way around, so converting algebraic expressions to word expressions. Before we actually get into any practice, I want us to do a little brainstorming. I've given you a bunch of words here, so there is 30 words, and you need to place them under the operation or mathematical symbol that they represent. So we have addition, subtraction, multiplication, division, exponents, radicals, which is, for all intents and purposes, the square root sign, because those are the type of radicals you've probably worked with the most, equals, and words that mean parentheses. So again, pause the video, take some time, sort those words into the categories you think they belong to, and then we'll review. We have to know what these words mean before we start problems, because if we read problems that have a word like this in them, well, we need to know what kind of operation or what they stand for. So pause and then come back once you've finished. All right, so you can now check your work. The words we have that represent an addition are plus, total, sum, increase by, more than, and added to. The only one I think you may be a little confused about is total. Maybe you think total represents equals because you're like adding a bunch of things together and then equaling something, but that's the whole idea. The total represent an expression where you're adding things together. So if they say the total of 5 and 17, right, that would just be 5 plus 17. Or if they said the total of 2 and a number and 22, it would be 2 plus a number, which we'll see later is a variable, plus 22. So total just means you're adding a bunch of things together. Okay, on to subtraction. We have words like difference, subtracted, minus, decrease by, and less than. Less than can actually stand for, right, a inequality sign as well, but we're not going to use those today. So when we say less than, today it's going to reference subtraction. For multiplication, we have a bunch. Product, times, multiplied by, doubled, tripled. Halved is on here. Halved is actually on for division as well, and that's because you could multiply by a half or you could divide by 2. Both of these would mean something is being halved, right? So you could have 1/2 times 5, or if you wanted to write it as division, you could have 5 divided by 2. So I think you could put halved in both categories. If you only have it in one, that's okay, but you can make an argument for both. And then we also have twice for multiplication. For division, we have halved, quotient, ratio, and divided by. If we move on to exponents, you may see words like squared, cubed, and raised to the power of. For radicals, again, I think the only one you've really talked about so far in your mathematical journey up to this point is square root. Equals, we have, well, equals, is, and equivalent. I actually had to add another category on here. Maybe you were wondering why there was something left out. So for parentheses, we have quantity. You may also see it as quantity of. And for variables, if you see a number. So if they just reference a number, but they don't say what the number is, we're going to need to represent that with a variable. I think there's square root is 2 words. Okay, so we're going to take these words and we are now going to practice using them and identifying in specific problems what signs, symbols, and numbers they represent. So we're going to go over here to another page. I'm going to put that up on the screen and then we're going to do some practice. All right, so we're just going to go through as many as we can until we get to about the 15-minute mark. As always, I encourage you to work through these problems before I go over them. and then you'll also have some to practice once the video is over. So the first one we're going to start with is 2. So pause the video, see if you can figure out the algebraic expression for number 2. Okay, so it says 10 more than W. So we need to figure out, we know we have 10 in W, but what does more than represent? Well, if we go back to our chart, we would see that more than represents addition. So there's only one here that has addition, which makes that nice, C. If there was a choice that said 10 plus W, we would also choose that. They would not give you both. So there would not be a fifth option that had 10 plus W. They would either have option C or option E for you to choose from, but not both. All right, we are onward to number 7. Okay, so now we have to write our own expression. We no longer have the multiple choice options. So twice a number. Well, when it says twice, that's going to represent multiplication. And a number is going to represent, well, we don't know what the number is, so we've got to use a variable. It's up to you to choose the variable. You can use whatever variable you want. People tend to use X, but that's just because that's what we're used to seeing. You could use C, you could use N, you could use S, D, doesn't matter. So twice a number is going to be 2 times X, or 2 times N, or 2 times 5. Not 2 times 5. 2 times G or H or any other letter. Okay, on to 10, which is 5 cubed. Now, we know that cubed represents an exponent, and specifically, if we are cubing something, that is raising something to the power of 3. So we have 5 cubed, or raised to the power of 3. 14 is next. Okay, this one looks a little bit more challenging. So we have -3 multiplied by the quantity of 4 and a number x. Okay, so we know we're multiplying -3 by something. Now we have to understand what the quantity represents. Whenever we see the word quantity, that's going to represent some sort of parentheses. So we're multiplying -3 by something that's in parentheses. Now, what immediately follows the word quantity will be inside the parentheses. So 4 and a number x, those are going to be what's inside parentheses. Now, 4 and a number x is just going to be 4 plus x. They actually told you what to make this number. They gave you a variable to use, so we must use the one that they tell us. So 4 plus x. It is important to note that there could be subtraction going on inside of the parentheses, but for that to occur, they would need to use a word that implies subtraction. So they would have to say the quantity of 4 minus a number x, or the quantity of 4 less than a number x, or the quantity of the difference of 4 and a number x. So quantity is generally just going to be things added together or something being subtracted. And if they just say 4 and a number x, that is going to imply addition here. So that's why we used addition. I just want to make that clear. And we are now moving to 19. Let's get rid of this first. So 19 is another multiple choice, but notice that we are now working the other direction. We are going from an algebraic expression to a word expression. So if you're just reading this right here, you're probably reading it as 18 divided by 6, if you're putting the operation in there. So quite clearly we see that's C. onward to 21. And you know, some other, actually before we get there, if you want some extra practice, you could look at these problems that are multiple choice problems and try to write what the expression would be for these different options, right? So the product of 6 and 18, well, product tells us to multiply, so we'd have 6 times 18. If I wanted to do 6 squared, well, squared represents an exponent of 2, so I'd have 6 raised to the power of 2. And finally down here, 18 to the 6. Again, when it says to the 6 or to the power of 6, that's going to represent an exponent. So 18 to the power of 6 or to the 6. So again, you could go, again, you want some extra practice once you finish the rest of the problems, go back to the multiple choice answers, and for the answers you didn't choose, try to rewrite them in the other form. So in this case, we would rewrite them using numbers and symbols, and up above, at the very top, we could rewrite all of these in words. So a way to get some extra problems if you want that extra practice. The next one we're going to is 21. Just to 19, we're off to 21. So we're writing our expression in words this time. So we have the numbers 2 and 4, and then we have a multiplication symbol. So you have some options here, right? And it's probably good to look at some of the words for multiplication that you're not as familiar with. So you could just say 2 multiplied by 4, right? That would be fine. 2 multiplied by 4. If we look at another word, we could say 2 times 4. And we could say the product, because the product implies multiplication, the product of 2 and 4. So those would be 3 different all correct ways of expressing 2 times 4 in words. All right, we are off to 28. Okay, 28, we have an equation, so we're going to have to use a word for that equal sign. Let's first think about what we have on the left-hand side. We have this n divided by 5, and you could say that, right? You could just simply say n divided by 5 equals 30. That's probably the most basic way to say it, right? But it's certainly correct. Let's be a little more creative. So instead of just saying divided by, we have some other words for division. We have the quotient. So the quotient of, and instead of saying n, we'll just say a number. So the quotient of a number and 5. And instead of saying equals 30, we can just say is 30. Remember, is another word for equals. And of course, there's some other tweaks you could make. You could say the ratio of a number and 5, or the ratio of n and 5 is equal to 30. There's always different ways we can recreate these statements. That being said, let's go to 29. So 29, we do not have an equation, but we do have an exponent. So we have to think about the ways to say an exponent. And this time our exponent is n. So we can't use squared, we can't use cubed. We have to use a word that we can use with any exponent, right? Because n could be any number here. So if we go back and look at our chart, the word for using a general exponent, we can say raised to the power of, or we can say to the power of. So we can start with 6 for sure. So 6, in 2 ways we could do it. We could say raised, actually more than 2, but raised to the power of n. We could also just say raised to the power of a number. We could also just say 6 to the power of a number. And again, there's also some other tweaks we could make. We could just say 6 to the nth power if we wanted to as well. Let's quickly do one more. I know we're at 15 minutes, but we can squeeze in one more. I'm going to go to 35. Very last one. So 35 is an equation. And on the left-hand side, we have r plus 8. So there are many words to represent addition. We could use sum. We could use added to. We could say plus. We could say total. We could say increase by. We could say more than. So it's really up to you to choose. I personally like the word sum. That's a word that I use a lot when I'm talking about addition. So I'm going to use the sum of a number and 8 is equal to 10. And I'd encourage you to try another way, right? So I'm gonna do one more. I'm gonna say 8 more than r, so I'm going to give you that variable. 8 more than r is 10. You know what? There's space for one more. Let's do it. So let's see. Let's use total. So we could say the total of a number r and 8 is 10. So 3 different ways of writing the same algebraic expression. Okay, you guys have plenty of other problems to work on. Remember, if you want that extra practice, you can go back and look at the multiple choice problems and write the expressions for the answers you didn't choose. If some of these are tough, if you have questions, if you're not sure if you can use a word here or there, note those problems so we can discuss them at a later point. I look forward to seeing you next video, but as always, enjoy the rest of your day.